Hey pre-callers, it's Miss Deloach here, and I just want to say hello and welcome to a brand new unit, conics. Conics don't really have a lot to do with trig. We have several random topics left this year. We'll visit trig again in the next unit, but right now we are taking a little break from trig and doing what's called conic sections. So some of them you've already heard of. A circle you learned about that in geometry. That's our first one. But we have other ones called ellipse, a hyperbola, and parabola. Parabola you know about. But these are shapes formed by cutting a cone, as you can see right here. And you're going to watch some videos that I did not make. This unit's going to be set up a little different than the other units because we're just trying to give you an overview. It's in Artiques. You're required to learn it, but we're not going to have you be super detailed. So you're going to be watching some general videos about applications and where they come from, and then answering a Google Doc about those. You do have a quizzes again, but I made sure that it was pretty simple and straightforward. So what you do need to know is, and you can use notes, of course, this formula sheet you may want to print out, but I'm going to walk through it with you to make sure you understand. So the first one we have is a circle, and that's when you cut a cone parallel to the base. So if you look right here, this cone was cut parallel to the base down there, and that's how you get a flat circle. And so HK is always the center of the circle and R is the radius, and there's your formula. So over here I have one that says x minus 3 squared plus y minus 2 squared equals 16. So the center is 3, 2. So if you look over here, if you go over 3 and down 2, that would be the center of your circle. Okay, so that's what that means, the center of the circle. And a radius of 4 means that this distance is 4. No matter where you go, it's a distance of 4. So center and radius is all you need for a circle. Notice none of these are functions. They don't pass the vertical line test, and they're not functions. The second one is an ellipse, and it is when you take this cone up here and you slice it at an angle, or you can slice it parallel to one of the sides. You could slice it parallel to one of the sides like that. And that will give you an ellipse. It looks like an Easter egg since we're close to Easter. So it's an oval shape. And the formula that we use for that is this one. It's x minus h squared over a squared plus y minus k squared over b squared equals 1. So it's a little bit different than the circle. HK is still the center, and A is the distance from the center horizontally, and B is the distance from the center vertically. So if we look here, we still have a center of 3, 2. So over 3 and down 2 is going to be our center. Okay. And then under here we have 2 squared. So that means horizontally I go 2 units, and that's how long that is from the center until I hit the ellipse horizontally. And then I'm going to go 4 units vertically. So up 4 is going to be 4 units before I hit the ellipse vertically. So this length would be 4, and of course going across would be 2. So that's how we know. And the center is at 3, negative 2. Okay. The next one is a hyperbola. And to get both pieces of the hyperbola, you actually cut 2 cones. So you have a cone like this that comes down, and then you have another cone right underneath it. So you have 2 exact same size. And if you slice like this, you would form 2 hyperbolas along the outside. So it looks a little bit like a sideways parabola. They can also go up, down. Hyperbolas can also look like this. They can go up, down like that. Okay, that's a vertical hyperbola, and this is a horizontal one. So to tell which it's going to be, if it's horizontal, the x is first in my equation, and if it's vertical, the y is first. So notice here the x is first, so this would be horizontal. This would be a horizontal one. And notice here the y is first, and so it would be vertical. And the big thing you need to notice about the equation comparing ellipse to hyperbola is that they're almost the same, but ellipse has a plus and hyperbola has a minus. So that's really important. Okay, so let's look at this hyperbola. The equation is x plus 4 squared over 3 squared minus y minus 2 squared over 2 squared equals 1. Well, I know that negative 4, 2 is the center because you change the signs on those. So if I go to the left 4 and up 2, I get right here, which is the center, negative 4, 2. And then I know it's going to open left to right because x is first, because x is first. And there's a lot about these numbers that are way high that we're not going to get into this year, okay? But because x is first, it's opening horizontally. The last one is a parabola, and you already know about parabolas, but it doesn't have to be an up-down parabola. This is a sideways parabola. That's not a function, the one I have drawn here. If it starts with y equals, it's going to be a vertical parabola, so what we're used to. And then if it starts with x first, it's going to be a horizontal parabola, so it's not a function. Okay? And again, HK is the center. Now be careful. So this first one, notice H is by the X and K is outside. In the second one, it's switched. So it's X equals, well, K is the Y value and H is the X value. So I have X equals, so this one I know is going to be horizontal. It's going to open left because this is negative. Since this is negative, it's going to open to the left. We'll look over here. This opens to the left. The vertex, okay, this is the K because it's by Y. So it's going to be, the vertex is going to be 4, 3. So if you go over 4 and up 3, that's the point 4, 3. And I know it opens left, okay? So that's basically the idea of what you need to know. You'll watch the videos and answer questions. Please feel free to comment or email me if you need any help at all, okay? I suggest printing this. All right, good luck. Bye.